Hello, Mr. Betts here. Let's take a look at an example of a problem where the capacity of a battery is decreasing at an exponential rate. So we have an exponential decay problem here. And essentially what's happening is the battery's capacity is going down by 5% of its current capacity each year. We want to know then how long it's going to take to get to 80% of its original capacity. So since we're looking at exponential decay, we're going to be using this solution to the differential equation where the rate of change of the quantity is proportional to the quantity itself. And we want to plug in what we can to figure out the values of the variables here. So essentially what we're looking for here is an amount of time for the capacity to get to 80%. But before we can get to that, we need to figure out what K is. And so we're going to use this 5% per year initial value here to figure that out. So one thing we know is that the initial capacity hopefully is going to be 100%. But we also know that the capacity after 1 year is going to be 95% because it's decreasing at 5% per year. So I'm going to use this right here to solve for K. So the capacity after 1 year is going to equal e to the k times 1. So we're going to have e to the k is equal to, I'll use a decimal here since we're going to be plugging into the calculator. And so we get k is equal to the natural log of 0.95. Okay, so that gives us our k value. However, we want to use that to figure out how long it's going to take to get to 80%. So I'm going to go back to this equation right here and say 80%. By the way, it would be even quicker to just say 0.80 equals 1 times e to the natural log of 0.95 times t. Okay, so this is the same thing as saying 80 equals 100. So I just did that division right off the bat. So solving for t then, we're going to take the natural log. And t is going to equal the natural log of 0.80 over the natural log of 0.95. So at this point, now I need to go to my calculator and plug that in. So natural log of 0.8 divided by the natural log of 0.95 is 4.350 years. And there you go.